Previously, we calculated the adiabatic mixing of two streams equation. Let's start the second lecture of this topic. First of all, we have already calculated the equations of adiabatic mixing of two streams. Now I am writing the equation m1 by m2 equals to h3 minus h2 by h1 minus h3. This is we get from equation number 1 and equation number 2. Or what we get from equation 1 and 3? m1 by m2 equals to omega 3 minus omega 2 by omega 1 minus omega 3. This is our entire scenario. From these two equations, we simply write down m1 m2 equals to h3 minus h2 by h1 minus h3 equals to omega 3 minus omega 2 by omega 1 minus omega 3. This is altogether our main equation. Now in psychometry diagram, how we draw for this type of process? This type of process how we draw in psychometry diagram. Let's start. First of all, we erase this. Now I am drawing one psychometry diagram. This is our T temperature. This is omega. This is our saturation curve. Here our enthalpy line. Now, as per our condition, two streams, 1 and 2, two streams mixes with each other and we get state 3. How we draw? First of all, let us assume these two are different states. We are assuming that state 1 is higher properties than state 2. Say higher enthalpy of state 1 enthalpy is greater than to state 2, or temperature. Temperature of state 1 is greater than to temperature of state 2. So first of all, we draw arbitrary diagram. First we draw state 1. Suppose say this is our state 1. Omega 1. H1. Now always remember that we are going to mix as 1 and 2. So this is our input. So first of all, in cyclotron diagram we draw 1 and 2. 1 is given omega 1 H1 T1. 2 is also given. Suppose because the temperature or enthalpy or specific humidity is lower than 1, the state of 1 is higher than the state of 2. So suppose state 2 is somewhere here. 2. This is our specific humidity omega 2 and corresponding the enthalpy H2. Now 1 and 2 mixes each other and we get state 3. For we have to locate the state 3. We don't know about state 3. We know about only 1 and 2. Because 1 and 2 is mixes each other, so we get a straight line. One minute. We get a straight line. We have only one equation. Already I have told m1 by m2 equals to h3 minus h2 by h1 minus h3 equals to omega 3 minus omega 2 omega 1 minus omega 3. This expression is our final expression. From our experience, we know this equation is linear interpolation. Linear interpolation. Linear interpolation means y minus y1 from in our mathematics x minus x1, y2 minus y1, x2 minus x1. In this equation, this is the equation, line equation. So suppose this is y, this is x, this is x1, y1, x2, y2. This is the linear interpolation equation. So where is the x and y? In our mathematics concept, we already know the according to linear regression, we get x and y somewhere in that line between x1, y1 and x2, y2. It depends on the coordinate of x and y or values of x and y. Similarly, from this equation, we get 3 point somewhere here or here or here or here. It depends on the value of 3. Value of 3. It depends on values of 3. Suppose first of all, this is the temperature of 1. This is the temperature of 2. Why we are about to learn this thing, because this is the concept of mixing. I have already told the mix. If we do mixing before conditioning, we will get low power. We will get high performance at the cost of low power consumption. Suppose say I already told 50% of outside air is exhausted from the room and 50% is mixed with the fresh air. Suppose this is the outside air one, this is the room, this is straight 2, this is our AC. AC. When first time outside air come in contact with AC, this is conditioned and goes to the room. After that, the conditioned air is leaving from the room and goes to the outside. If we want to